Doing live. Hey, Amos. What's up, buddy? Good morning, man. Good morning, bro. Happy Sunday, fun day. Hey, Mark. What's up, buddy? Awesome, man. Okay, so I got my 2 PC stream setup going now. So we're gonna try that out today. Hopefully I don't have any issues with audio or anything like that. Let me know if the mic's too loud or the music's too loud. I'm not gonna have the music on when I switch over to the web pages, but right now while we're starting up and waiting for people to come in, I'm gonna play the music, and I'm going to just share out the link. So if you guys hit the like button and share me out, that'd be super awesome. Good morning, Konaman. Happy Sunday, my man. Good to see you, buddy. This stream was inspired by you, of course, Mr. Konaman, sir. The materials. So I was exploring materials further, and there's some new things out there that I hadn't seen yet, which are pretty cool. So, not a lot. I'm taking a repair day off. Well, sort of. Good. Okay. That's good. Yeah, I tore this whole place apart yesterday, rewired everything, rearranged everything. It's pretty crazy looking. So I got now the backside there, all that like to clean up, and yeah, man, I got all my wires organized, and it looks like, you know, cable management's good, everything's nice and clean. You know, I cleaned all the parts, and man, these two, like, this is crazy. I got these 2 massive towers now, PCs. They're both gaming PCs on either side of me. Let me see if I could kind of show you maybe on the Brio. Fucking Stream Deck ain't gonna work for me or what? Fuck me. My Stream Deck ain't working right now. What the fuck is going on here? Oh, maybe that's why. It'll help if I start it up, but hey, guy. Alright, there. I guess I should open Stream Deck for it to work. Alright, so go 4K. If I go to the Brio. Yes. Okay, because I need the Stream Deck to work for when I'm on the other system using the NDI to when I'm going on the web pages and stuff like that, and I'm on the other computer. I need the Stream Deck to control my scenes, right? Otherwise, I won't be able to control my scenes. Yeah, that's funny. 2 PCs for the Barbie Dreamhouse game. Right on. You can see the top of the one here, and then there's the other one there. Yeah, the camera, I got the mixer over here now. The router's on this side over here behind me. But it's more late. It's better, you know. It's definitely more organized. I got the KVM switch, which is how I'm using the 2 PCs. I'm just using one keyboard and mouse. So hopefully the KVM switch doesn't mess with my stream and the NDI. And everything works smooth. Okay, that's what I'm hoping for here. So we're gonna try it. We'll see. And then while I'm over on the other PC on the web pages, then I can use the Stream Deck to control my scenes. Yeah, right. Hacking to NASA. Yeah, buddy. Sweet, dudes. So I'm just gonna finish sharing out the link here real quick on the Twitter and stuff, and we'll rock and roll, man. Oh, that's too funny. Alright. Hopefully it shows the damn picture this time. Oh, right on. Yeah, man, I'm probably gonna pop into Creativerse today. Fuck, it didn't add the picture again. Hey, Jelly Duck, buddy, I just missed your stream this morning. I saw the link and I went in, but it was only like 36 minutes long. Just missed you, man. So that's done. How's it going, Jelly Duck? Good to see you, buddy. Oh, shit. Hey, Maintenance Man! What's up, buddy? Good to see you, man. Good to see you guys. Good to see you, man. I think I'm gonna share this out on maybe 1-2 more pages, and then we'll get to it. Is it gonna work? Is it gonna work? Oh no! You got copyright claim on it, eh? Was it music in the background or something? Okay. Oh, there it is. So stupid. Oh, yeah, that's not nuts. I think that's nuts how that happens. Oh yeah. Yeah, buddy. It is good to see everybody. Yes, you bet. Good to see you too, man. It's been a while, feels like. I think I missed a couple streams last week, eh? But yeah, I'm just sharing out the link right now. So you guys give me a thumbs up. That'll help me out a lot. And we'll get to the pages in a minute. I got some pretty awesome materials. Some good stuff we can explore today in materials. A lot in all. Yeah, that is true. That is true. Yeah, I think I'm like 15, 16 subscribers away from 2,000. So we're pretty close. We're pretty darn close to hitting 2,000 subscribers. So it's pretty dope, man. It's pretty dope. That's another good milestone to hit. Yeah. I guess I'll go to LinkedIn, and that'll be it. Well, I'm just gonna post it on LinkedIn, and then we're done. No, wait, discovering new building materials. Why does it do that? Why does it do that? Why does it do that? Oh, there it is. Okay, get rid of that. I'm gonna add that. All right, and the hashtag. Oh, construction worker, construction life, construction project. Management, contractors. Okay, we're good. Posts, and we are done. Yeah, okay, so Chris, to my copyright, you cannot use visual. I put a copyright on your image. If you like to use it, let me know. My lawyers are ready. Thanks, man. Okay. Now here's where it gets good. Now we're gonna get into the stream. We're gonna go and look at some pages. We're going to hopefully everything works. Hopefully everything works. I'm gonna turn the music off because I don't really need it, unless it's low enough. It doesn't bother anybody. I don't know. If anyone wants the music, let me know. But I'm gonna pause it. Pause it. All right, so live dashboard, everything looks good in green there. I'm gonna move this over to here, and I'm going to close this because I don't need it open right now. Okay. Now for the fun part. So if I go to, I gotta now switch over to my other system on the monitor. So then I'll be controlling this monitor and this off of the Stream Deck. Now, hopefully I can leave the chat on this side. And wait, I need this here. And I want that there, and this here. So I can see everything on that. Hopefully the chat keeps going on there, and it'll pick it up as well through the NDI. Okay. Let's go. Okay, actually, I'll switch over to that scene first. Okay, so that screen's on my other computer. I want to make sure the chat comes up in it. Let's make sure. Even Sunday morning, Sunday fun day. Yeah, buddy. Yeah, of course. Sunday fun day. I'm going to write that down. Sunday fun day. Boom, ba, da, boom. Make sure that chat's working here. Oh, fuck. Properties. There we go. There we go. Beautiful. Now it's working. Okay. So, I gotta switch over to the other system and hopefully everything works good. Boom. I got to the hospital yesterday at around 1. Still tired once then and then. Oh, yep. Ooh. Oh, gross. Yeah. Oh, man. Yeah, I hope you feel okay, buddy. Radiation? What? Oh, yeah, because you're getting, getting looked at, right? But, yeah, you do be tired, man. Chill. This could be a fun stream. Like I was saying, this was inspired by you, my man. So, make sure you guys can hear everything. As long as the audio is good, you guys can hear me. We're good to go. I don't know if the audio, if I play any videos over here though, that might be a trickier one too. Shit. I wonder if I should add an NDI audio source real quick. Hold on here. Let me just double check. I'm gonna go back to the other computer. I might have to add another audio source before I go to that page. Just make sure. If I go here, NDI source, add source, it'll be a new source, audio, add source, oops, hold on, your cancel, delete, or hold on, your cancel. I screwed that one up. All right, let's see here. Audio capture device, maybe, or audio input capture. Let's see here. Add a new source and NDI audio. Hopefully that'll work. Yes, I think this will work. NDI audio. Done. All right, so where is it now? NDI audio. NDI audio. Okay, well, we're going to find out. We'll play a YouTube video on the other one. And yes, sorry, guy. Okay. Now we're good to go. Oh, I need one more thing here. There. And now, boom. Okay. Sorry there, Amos. This is a test stream too. Yeah, well, I've just remembered. Hey, Max B, what's happening, buddy? Let's go to. Oop. Let's see what happens when we type building materials 2020 on YouTube. 5. Okay, here we go.
Hi, welcome to Cool Gadgets and Stuff. In this video, we are going to take a look at some alternative. Hemp was finally legalized in the U.S. in the 2018 Farm Bill, and farmers are showing a
How's it going, Max B? How's it going, buddy?
Hemp for industrial and
Can you guys hear the audio
use.
on that?
Hempcrete is one of those bio-based materials that can be
on that
used
video,
to
can you guys
build,
hear audio?
renovate, and restore all types of buildings. EcocoCon, a company from Europe, have developed a unique straw building technology. Their compressed straw panel elements provide...
Oh, you guys can hear? Oh, awesome. Can you hear it now? I just can't hear it. Unless I switch the audio over from here. Oh, okay. So now you can't. Okay, good. Oh.
Team of 3 people can assemble around 100
now you can
square
hear
meters,
it, right?
or 1,000
cool. That's
square
cool. Now I
feet
just
of
need
wall per day.
to set the other side so I can hear it. One.
The EcocoCon straw panels
awesome.
provide a load-bearing construction element, and at the same time, the main insulation
this
of the
could get
building.
confusing.
Clay plaster can be applied directly on the inner straw surface and lime to the outer. Panels have a dense and strong structure, allowing for all furniture, electronic devices, pictures, etc. to be mounted on the walls using ordinary wood screws. EcocoCon panels can be used for building homes with 1 or more stories. These panels meet all building regulation requirements for resistance, compression, durability, and
okay, well that one's going to be hard. I'm going to have to figure that one out another time. All right.
The traditional way of bricklaying is slow, tedious, and costly. Interlocking bricks are designed to lock itself to other bricks
the straw knew
without
that.
the use of mortar to form a structurally stable home. Just dry stack the bricks, pour in an inexpensive mortar,
I won't be able to
and
hear
add
video,
steel vertically to reinforce the walls. It's a simplified brick and mortar concept, similar to stacking Legos. This system requires no plaster work, less cement, fewer workers, and is a lot faster to build, which equates to lower costs. It is also very intuitive and simple to learn for everyone. Interlocking bricks can be made from different materials, but most common is soil and cement mixture. A pressing machine is used to compress the bricks, which are then cured for a while, so the cement sets and bonds with the sand, stabilizing the brick.
What in the hell happened here?
This compacted brick also has better thermal insulation. Using the interlocking brick building system, you may save costs by eliminating formworks for reinforced concrete columns and beams, plastering and painting costs, and reducing the workers, materials, and time. This wall can also be plastered and painted just like any other wall.
What the hell is this, guys?
Bamboo has a long tradition of being used as a building material throughout the world's tropical and subtropic regions. Bamboo, a type of giant grass with a woody stem, is a natural composite material with high strength to weight ratio and provides ample sturdiness to structures. It can grow exceptionally fast and is extremely flexible. Bamboo is considered to be a sustainable and renewable alternative to hardwoods, foremost because it regenerates at exceptionally fast rates. For bamboo to be used as a building material, it must be worked on to create the desired shape, bend, and length to be used for structural or other purposes. A thorough treatment of bamboo is required to protect it against insects or rot before it is put into use. It can be used to build entire homes and other structures that are earthquake resistant and can survive strong winds and storms. Bamboo living homes
it
have
does.
been
There we
designing
go.
custom prefab bamboo
There we
homes
go.
that can be shipped
Now
all
it's
over the
working.
world.
Now I can hear it. Okay.
Prefabrication or
Beautiful.
prefab homes are manufactured inside a
Final
controlled
test.
environment.
As long
in
as you guys
sections that
can
are
hear
easy to
me and the
ship
video
and capable
on there,
of
we're
being
good.
reassembled on
So,
site.
let's
Their
get to
bamboo
her.
construction will meet the requirements of the world's most stringent building codes.
Beer in your hand, yeah, man.
One company is
I
converting
drank
plastic
a
waste
couple,
into
Guinnesses
construction
yesterday.
material. Biofusion has created a
I
solution
turned
to the
40.
plastic
It was my
waste
birthday
crisis.
yesterday, so yeah,
Biblock
thanks for
is the
saying
first
happy birthday to me
construction-grade
yesterday.
building
Amos, on
material
the
made
stream there,
entirely
and
from
then
recycled
all you guys
plastic
reached out
waste.
to me on
A machine
Facebook.
dubbed the blocker turns plastic debris into construction material. It
Oh my
shreds the
God.
plastic.
What the hell? Okay, 18 new building materials that will revolutionize construction. Throughout the ages, we've seen the construction industry undergo a series of building material innovations, from durable concrete used in ancient structures to the production of steel for bridges and skyscrapers. These materials shape the way we build today and influenced some of the greatest architectural feats, while some materials have simply evolved over time, like concrete and marble. There are newer cutting-edge materials being developed on the horizon. Thanks, guy. Thanks, dude. Yeah, no worries, guys. Yeah, cheers, man. Oh, man. So what's the drive behind these innovations? Despite its growth, the construction industry faces a number of challenges, from natural disasters and sheer costs to environmental concerns and efficiency. The industry struggles to keep up with demand while maintaining its output. Building projects consume 50% of our resources from nature, often leading to added costs, delayed construction times, and wasted materials. 50% of our resources goes to building materials, or construction projects. Isn't that something? That is crazy. So what are we talking about here? Aesthetics. Materials are being engineered to be smarter, stronger, and self-sustaining, sleeker, and easier on the environment. The BIQ house in Hamburg, I love that, Hamburg, Germany, provides a perfect glimpse of the future. Oh, wow. So the BIQ is able to harness its own electricity, not only due to its aesthetics, called to mind impressive sci-fi buildings from pop. All right. The BIQ house. Let's check it out. Copy. Algae, future energy source. Okay. This right here caught my attention. I have to check this out. Oh, absolutely, maintenance man. Yeah, buddy. Yeah, you bet. Thank you for stopping by, son. Right on, dude.
The IBA.
Cool, dude.
7 years
Have a
in the
great day with
making,
the kids,
the
man.
exhibition wasn't just about showcasing innovative buildings, it was about regeneration of a relatively poor neighbourhood of the city, with sustainable living in mind.
The real access will be visible, let me say, in 5 or 7 years. But until now, today, I can say we are more successful than I would have expected for today.
So what innovation was
hear the video
showcased here
fine?
that made
Is
it
it too
such
low?
a success? Well, first up, there was Wood Cube, a 5-storey carbon-neutral apartment block constructed almost entirely from wood and gets its power solely from photovoltaic panels.
Wood has a new boom, a new career as a construction material. And what we built 5
they do.
different wood houses with completely different
But smell great.
technologies, but all based on wood. And that is, of course, very interesting for the different construction firms to see how people respond to these different materials, to these different technologies. And so I think we will see in future which materials, which technologies will succeed and which will fail.
And finally, the IBA showcased a world first, BIQ,
Yeah.
a building with its own bioreactor that runs entirely off algae.
Whoa!
The sun-facing sides of this structure are covered with water tanks where algae bask in the light. What happens next is truly innovative. The systems designer, Martin Kerner, gives an inside look at his groundbreaking bioreactor.
Oh no!
What we produce
I hope
here
the audio doesn't get me
in
in
this
trouble.
vessel is to burn biogas, and we produce
Look at
our
that.
flue gas. And the flue gas contains CO2, and the CO2 is transferred into our culture medium by these saturation devices. So we saturate the water with flue gas, with CO2, and then transfer it back into our bioreactor facade so that the algae can take up the CO2. With this device over here, we add nutrients. That means mainly nitrogen and phosphorus.
Do you see this,
to our
guys?
culture
This is
medium.
insanity.
With these large
This is
tubes
really
over
good
there,
stuff.
at the roof, we take out the heat from the culture medium and transfer it into our heating system of the house.
But it isn't just heating that microorganisms can produce. This reactor can also farm excess amounts of algae that can be harvested for an entirely different reason.
This is rich in proteins, it's rich in unsaturated fatty acid, it
Oh, wow.
contains vitamins, minerals and so on, so it's physiologically very positive.
Who would have
And we
thought
would like
that?
to make food and feed,
Like that's
out
a
of, feed
really
for animals out of
that's
this
something
biomass.
really
So this
interesting.
bioreactor
like,
has the capability of
bioreactor.
not only heating our homes, but also of feeding our livestock.
feeding livestock and creating energy. That's interesting. That's really good stuff. That is really good stuff. The BIQ house. Could you imagine that? If you build it, they will come and inspect it. Yeah, at least they should come and inspect it. I keep saying, guys, I need to get an electrical inspection done on this place here that we this house here. Like, I think the guy who lived here before us was messing around with it. Good to see you. Free to laugh now. How's it going, man? So that's cool. So the future of building materials, 18 innovations. A new generation of stronger, lighter, and more sustainable building materials is coming to solve the construction industry's main challenges. And here are the most promising materials set to change the way we build. For cleaning city, but I'm no engineer. Of course he's German. Self-healing concrete, yeah, that's definitely the most exciting thing to come for sure. There's no question about that. So there's bacteria. We know that there's bacteria in the construction. So when it cracks and water reacts with the bacteria, it forms more concrete to seal the cracks. So 200-year lifespan on the self-healing concrete is pretty good, pretty awesome. The 3D graphene, yes, 3D printing is going to be pretty huge, I think. When it, like, dudes, have you seen the ones that print metal and they can like literally just print metal parts? Like it's really something to see. Cleaning city air. Yeah. Yeah, that's the thing too. There's building facade materials now that scrub the air. There's certain concretes and certain other materials that scrub the air, and I think that there will be a lot of that in new urban development. Because the air quality is not as the greatest there, right? In the cities, so I see the air scrubbing material is going to be pretty cool. I'm sure we'll come across it here. We usually do, but yeah, the 3D printing is the path of the future. The idea of having like zero waste is fantastic, right? Like to be able to print exactly what you need is pretty awesome. The accuracy, right, with the technology, with machine learning and the AI, the augmented intelligence, right, it's pretty interesting to see how quickly too, right? Like how accurate things are gonna get. The scanning technology, like sensors, all this stuff is gonna be pretty impressive. Even now, it's crazy how accurate they are. It's pretty impressive. So it's 3D printed carbon that is 5% of steel's density, but up to 200 times its strength, right? That's pretty cool. So vehicles and potential supporting skyscrapers to 98,000 feet. Aerographite, so 75 times lighter than styrofoam. World's lightest building material, so it's called aerographite. 75 times lighter than styrofoam. It's an atom-made materials that have the ability to grow stronger when compressed. Uses, potential use for aviation materials, satellites, and purification systems. That's wild, eh? 75 times lighter than styrofoam. Laminated timber, interesting. I know we're talking about cross-laminated timber. I think that's what this means. Yeah, laminated timber. Yeah, it's just pieces compressed and pushed together. Prefabricated timber with higher water resistance and strength over traditional wood. Potentials to support skyscrapers and reduce 150 tons of carbon per story. 150 tons of carbon per story. Isn't that unbelievable? Yeah, 75 times lighter is it's just, oh, wow, right? This is neat here, modular bamboo. Super sturdy and eco-friendly, low cost and fast growing material that can extend into different shapes and structures. So building earthquake resistant buildings, creating new architectural forms, and reinforcing steel bars. Bamboo, modular bamboo. Nanotubes for building, carbon nanotubes. Yeah, that's the carbon nanotubes are the little tiny things that go into these materials. I think that scrub the air, right? They're pretty neat. Transparent aluminum, the transparent aluminum, the translucent wood, light generating concrete is another one. We've seen that one too. The aluminum, right? So ceramic alloy that is 85% harder than sapphire and resistant to corrosion, radiation, and oxidation. Uses or possibilities include windows and domes for undersea and space vehicles. That's pretty cool, yeah. The translucent wood, color strip wood with better insulation strength and biodegradability. Uses for solar panel cells, window glass replacements, natural indoor lighting, and contemporary structures. Pretty neat, eh? What's this here? Microbial cellulose. So, what it is, a mixture of bacteria, yeast, and microorganisms able to form layered structures for signage and facades. That's stronger than steel, 98% water. Graphene is carbon. That's that's this is the kind of thing that like when you're sending vehicles to space or to say like another planet to build a colony or something, they want to build structures before people get there. They can harvest materials from the atmosphere, right? Like that's what we're trying to figure out. What materials like these 3D printing robots or whatever can use, they can harness to and to be manned, unmanned or unpersoned or whatever. You know what I mean? The wool brick, yeah. Nanocrystal, aluminum foam. Okay, so wait a minute here. Okay, so synthetic spider silk variants could be used for acoustic building tiles in laboratories. Spider silk, oh yeah, duh. Wool brick, nanocrystal. Yeah, pollution absorbing brick. So double layered insulated brick able to filter 30% of fine pollutants and 100% of coarse pollutants, releasing filtered air and sustaining ventilation for green buildings. It doesn't say what's in them, but hydroceramics, a membrane made of ceramic fabric and hydrogels that can absorb up to 400 times its volume of water. Biochar. Oh, charcoal to increase soil productivity. Biochar. Neat. That's the first time I've heard of this. So biochar, a waste product material with high insulation qualities produced when tree debris is burned in pyrolysis kilns. Pyrolysis kilns, sorry. Or pyrolysis kilns. Pyrolysis kilns. God. Provide thermal regulation and creating more sustainable, self-reliant buildings. Cool. So invisible solar cells, bioreactors. So that's the algae thing that we were just watching, right? Algae-infused building panels that can undergo synthesis to create energy, to provide thermal regulation, and to create a more sustainable, self-reliant buildings. But neat, man. You put your wood ashes in your garden, and that's I didn't know that you would do that. Like, I wouldn't have thought to do that. Yeah, prefabricated laminated timber, self-healing concrete, 3D graphene, transparent aluminum, bioreactors, invisible solar cells, synthetic spider silk, nanocrystal, translucent wood, aluminum, blah, blah, blah. Anything here we haven't seen? Hydroceramic. So hydroceramics are the self-cooling walls of the future. These walls are made to form 2 layers of ceramic, fabric, and hydrogels. These new building materials in architecture can absorb up to 400 times its volume in water. When used in buildings, it cools a building temperature and saves greatly on HVAC costs. You mix the ashes in your compost first. Cool. If there's anything you guys want to take a closer look at of this, let me know, and I'll search for a vid or something like that. Let me know. How's the stream so far? Everything running smooth out there? Looking good? Sounding good? No. I got also switched to ultra low latency, which is cool on YouTube. So I hope that would be. Oh yeah, dude, you bet. I know. I filled up a thermos today with a second coffee in it, so I'm good to go, which is dope, man. I don't know. Let's see here. 10 cutting edge, energy efficient building materials. Oh, so this is. See this here. This is a polyurea coatings. I've seen this a lot in the ceiling. Sorry, they use it for fire rating. I've seen it in a lot of buildings. Almost every building gets at least some of this in it. And it's like I think it's like recycled newspaper and glue and stuff like that. It's not very good to breathe in, but once it's dried and solid, it seems to be okay. Like, it does settle. But when you're like drywalling around this stuff, oh my god, it is the worst. Okay. We call it cellufiber. Cellufiber is what we call it. But that cellufiber and this polyurea coating could be different. But it's nasty shit, dudes. It's nasty shit for working around. So let's see here. If you want to build with walls of rammed earth or adobe, the great advantage is that the material is abundant, free, and doesn't have to be transported to the job site. The downside is that you'll have a hard time finding specialized craftsmen who know how to build with dirt. So yeah, this isn't on that, but you know what? I'll show you guys. Let me show you what it is. Polyurea spray coating. Minute 15. Wow, there's not a lot of information on it. sure. You had to do that. Oh, what? Fast setting. Oh, yeah, no, that's not it. That's not it. Let's see if I can sell you a fiber. Oh, come on. That's... Wow, that's crazy, eh? That's crazy. That's a crazy coding. The Airgen Tech I mentioned a couple weeks ago fits into today's stream topic. And he says it was developed at the University of Massachusetts Amherst. Cool. Okay, Airgen Tech. Let's check it out then. Because I can't find cellular fiber. I'll have to figure out what it's called, but you don't... Oh, yes, the air-powered generator, right.
Juicy. Gen, a cheap and simple alternative to existing wind-powered generators.
Oh, look at that.
7 years ago, there was
Look
questions
at see the
posed to me
green
about
green screen. The guy's in front of a green
why
screen. That's
people are
awesome.
in the dark. The fact is that there's only 1/3 of the world that has reliable power. You can walk into a house at night time and throw a switch. Your TV works, your appliances work, they all work. 2/3 of the planet have nothing. They're in darkness. Major corporations are not about to put this infrastructure in. If they were going to solve this problem, it would have been solved years ago. The only way you get power to these remote communities is through this device, and devices similar. With power, you are liberated from the dark. The unit itself is simplistic in its construction. You have your top plate, base plate, which is called the annulus, and the aerofoil. The generator is inside, which is also the axle. You have your regulator, battery power to inverter, 240 volt output, plug straight in.
It's all in one
Simple
little
as that.
unit. Wow.
This is not complicated.
No.
The majority of these electronic components
That is amazing.
can be bought off the shelf. There's very little weight in this unit. It is incredibly portable. It can be flat packed and taken anywhere. You can cart this on the back of a yak. Built by a community for a community. One of the assets of this particular design is that it can be upscaled or it can be downscaled. This is a smaller version, but you can see the construction technique. It's quite...
Look at that. That is wild. If I had an acreage or whatnot, I would have wind power. Absolutely. I would have a big windmill. I would definitely use solar and wind. Oh, look at that, eh?
So a lot of friends.
That's the music that's tripping me out.
Around me. We started working on this project. It takes a long time to bring things to fruition. I'm incredibly proud of what we put together, but we know we can lift its efficiency. By how much? Only R&D will solve. We need computer-generated modeling. We need wind tunneling. We can streamline this. We can streamline the manufacturing, the cost of manufacturing, the efficiency, the power output. In prototype, it cost me $700 to get all these elements cut and folded.
In prototype.
In prototype. In mass production, that could be brought down to $100, maybe $2.
Yeah.
We need a community of like-minded people around us. I'm not precious about this technology. There are blueprints available of these 2 primary units. You can take those and try it out yourself. It is a shared technology. It's the only way we're going to get it across the planet. We can all together push this product forward, reduce the costs, up the power, and have it transportable and flat packed throughout the world.
Yeah, that's wicked, dude. I'm going to check that back out after. Oh, shared tech, of course. Of course, shared tech is the bomb. Everything open source, shared tech is the way to go. It's the future. Without collaborating and working together, we have this finite mindset. And that's what's destroying this planet and destroying our relationships with each other. If we were to think in an infinite mindset and work together, collaborate, like the world would be a better place. That to me is something that, you know, I'm very passionate about. Very, 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 very passionate about, Amos. It's pretty important to go that way. Yes, I know you do for sure. I know you do. I think it's really neat. Like, we need to, like, the sharing of information and putting out the awareness. It's awesome. Like, it's so hard to break into this technology and construction niche, right? It's a really uphill battle, and the guys at the top are still, like, you know, they're still they're hanging on to their piece of the pie pretty tightly, you know what I mean? So we'll see. In time, hopefully we'll beat through that barrier, right? Custard cream. Ooh, coffee and custard creams. Beautiful. That sounds awesome. Courtney made me the best dinner in the world yesterday. We were going to make manicotti, but the grocery store didn't have manicotti shells, so she got something new. They're like these jumbo pasta shells, and like the shells, right? Like they're like, you know, those seashells, but they're jumbo. And we stuffed them with the manicotti recipe, eh? And oh man, they were so good. I ate a big bowl. Oh man, I'm gonna eat some more too. Start the countdown. Okay, so the drive for energy efficient buildings comes down to a quest for the so-called tight envelope. Oh, that's a new term, tight envelope. In builder lingo, the better a structure keeps out the wind and the rain, the tighter its envelope. Okay, that makes sense. Right? Like I'm a big fan of real rain screen systems, like with cladding. I love the metal cladding. I'd love to do a system here on this house even. Like, it would just be boss. And if you can achieve that tight envelope while using some kind of renewable, recycled material, then that's all the better. But while many new energy-efficient products enter the market each year, some builders shy away from them because of higher costs. In many cases, just adding a layer of insulation or a specially glazed window can increase the cost of materials by 20 to 30%. That's a problem, right? That's a big problem because, you know, that's the construction industry, right? Builders and even owners want to build cheaper, right? They want to have the most beneficial outcome to the least least cost, almost, right? Oh yeah, buddy. Oh, no problem, Kodaman. Thank you so much for coming. God bless you, man, and love you guys. You take care of yourself, bro. Yeah, you know it, brother. Yeah, right on, guy. Yeah, rainproof is right. Yeah, me double mark. Yeah, it's Oh, is Jelly Duck still here? Because he has to tell me his name again. I don't want to mess it up. Amar. I can't remember Jelly Duck's name again. Damn it. I'm so sorry, bro. Air and waterproof. So it's air and rain, both. And so the tighter you can get both, then the better, right? Perfection Construction, Edmonton and area. I love how these personalized ads, right? Like, recycled steel. Usually interesting. If you check out the material produced by Steel Recycling Institute, SRI, you may want to skip the wood beams when building your next house. Building your next house, you might want to skip the wood beams. According to the SRI, builders are simplifying the framing process by ordering customized steel beams and panels to fit each specific design. The SRI touts the durability of steel in areas subject to high winds and earthquakes. Further, it reports that while a 2,000 square foot, 186 square meter house requires 40 or 50 trees to build, a frame from recycled steel would require no more than the material that comes from 6 scrapped cars. That's good, right? That's interesting though too, because we might see a shift of steel and concrete going more into residential, and wood and more traditional house materials going to skyscrapers, right? Yeah, we can see. I can see a shift going that way almost. So. I think that you do need some sort of like an air barrier in there to neutralize the system almost. Like it's more of a like a heating and cooling thing, right? It's more to do with thermodynamics than with moisture protection, right? Yeah, like the 1 inch airspace, for example, right? You will see that in almost every facade design. You'll still see that 1 inch airspace in there, and a lot of the times, like when you're building a wall off a CMU wall, you want to leave another inch space between the back side of your wall and the front of the CMU. A lot of that, to me, like when you're building an internal wall like that, is because you don't know if the CMU is level, and you don't want a crooked wall. You want yours to be perfectly level, right? So you bring it out so that it doesn't. Yes, concrete masonry unit. Sorry, those blocks, right? Like 8-inch, 10-inch blocks. They're called concrete masonry units. Sorry, yeah, the CMUs. But it's also like a thermal bridge almost, right? In my opinion, I think that's what their mentality was. When you're insulating and doing poly, for example, you that's where you want it airtight. You don't want to have any air pockets. So when you insulate a wall, you are technically supposed to have the insulation coming out of the wall, like past the studs, and then when you pull the poly in nice and tight, it pushes it back in tight, right? You don't want any airspace between your insulation and your vapor barrier. That's where condensation will build up, and mold and frost and things like that will gather up. As long as there's no air pocket in your wall part on the inside between the membrane, right? Then you're good, right? Air barrier, vapor barrier. Well, see, like, and that's like they still only really use Tyvek on houses, right? That is really weird to me. I mean, Tyvek, I don't like. Tyvek is like really an old school product, you know. It's really I think to be a real effective like air vapor barrier, you need to apply a membrane of some sort to your wall, and then it's like I was saying, right? If you have like a nice solid membrane and insulate to it with rigid or semi-rigid, right? And then on the outside of your insulation, you'll have the air pocket, right? Like a 1 inch air pocket on the outside of the insulation before your cladding or whatever. Okay. But yeah, I mean, I think that sure, yeah, they didn't have a lot of I'm not sure if they understood it completely. We've been building the same way for a long time, and I think that like when you look at building with rocks and mortar and things like that to now framing and insulating and all that, it was quite a process. And yeah, the testing and technology has just gotten so much better. We know so much more about how materials react in their environments, right? It's just, yeah, I think it's more information now, right? Does that make sense? If I'm just talking around in circles. That's pretty good though. Insulating concrete forms those are pretty decent. Yeah, Matt Rissinger, I watch him too. Yeah, Matt Rissinger. Actually, I think you just told me about him, and I started watching him a couple of weeks ago, maybe, or a month ago. But I think, yeah, you're the one who told me showed me him. Sorry. But yeah, we all know insulated concrete forms. I think they're pretty cool. It's everything's insulated and everything's got structural ties, even structurally, and it's insulated. And as long as you get the concrete in there, vibrate it in, and make sure it's good and strong, and you don't get too much water on the top, you're good to go, right? Yeah. Me double. Yeah, and there's some houses that like I've seen old stone houses like they did that here as well back in like the 1800s, and it was like a lot of the old farmhouses and stuff were all stone structures, and that's like what I mean. It was a solid wall. Okay, but it wasn't very. I think those walls carried a lot of cold, right, through them. So they could be really cold walls. But then when you start putting, say, straw in there in the middle, it gives you a bit of a thermal break, right? So. Plant-based polyurethane rigid foam, plant-based. So that's different. After the #1 maker of surfboard material went out of business and was fined by the Environmental Protection Agency for using a toxic chemical, a surfboard maker in San Diego started producing a foam material that comes from plants. The so-called rigid foam is used in insulation, wind turbine blades, furniture, and of course, surfboards. When used as an insulation, the foam offers high moisture and heat resistance, excellent acoustics, and protection against mold and pests. It also has a higher R value than fiberglass or polystyrene, meaning that it has a higher thermal resistance and insulates better. That's the one thing I've thought, because would rigid insulation have a better sound barrier than bad or the semi-rigid? I think the little bit of air is good, I think that little bit of air in the mineral wool or in the bat is good, right? Absolutely, Amos. That would be really awesome. Hopefully one day we can do a project something like that and build something smart. That would be a lot of fun. Ever build with Legos? Straw bales? Okay, then you can build a house. That's the philosophy of Mark Jensen, who supervises the building of straw bale houses for Native American communities. Straw is a byproduct of the grain industry that would be burned otherwise. So that's how we fix the housing crisis for them, with straw bale houses, eh? And I'll huff and I'll puff and I'll blow your house in. It would be very high, Mark. The cost is fairly high. I have connections in that industry, right? For materials and installers and all that stuff. So I could get it at a better price for sure. But yeah, it is an expensive product. The joinery method. On my side of the pond, yeah, that's right. That's the unfortunate thing too, right? Cool roofing, not cool runnings, cool roofing. So the Cool Roof Rating Council explains it like this. If you want to stay cool on a hot day, it's better to wear a white t-shirt than a black one because it reflects rather than it absorbs. A cool roof is like that white t-shirt. It reflects heat from the sun and stays cooler, thus transferring less heat into the building. Now that is one thing that has never made sense to me. Why shingles are always dark, or why why are they dark, right? Why are we not using a color that reflects natural sunlight? Why are we absorbing heat, right? And metal roofing is the best. I agree, absolutely, 100%. I love a metal roof. Yeah, these structurally insulated panels, nothing new there. It's like Kingspan and stuff like that, right? Recycled wood and plastic composite lumber. That's nothing new. Low E windows. The low E in low E stands for emissivity, and clear coating of metallic oxide on these windows keep the heat inside the house in the winter and outside in the summer. The vacuum insulated panel. Yep. Yeah. Those sandwich panels. And that's that. What do we got here? Oh yeah, concrete, Roman concrete, fur rock. Roman concrete. Yes, shingles are oil-based, Amos. They are. They're a petroleum-based product. A British Petroleum makes shingles. Okay, BP makes shingles. Concrete has been. Let me see here. I need a hotter coffee here. Oh my goodness. Oh, that's it. That's the good stuff right there, baby. Concrete usage has been dated back more than 2,000 years, and the Romans were one of the first major civilizations to use the material. Yeah. Fur rock. So in addition to some major structural flaws of modern concrete, the product also has a substantial environmental impact. On average, 4 billion tons of cement is produced annually, making the cement industry one of the primary producers of carbon dioxide, creating around 5% of the world's man-made emissions of this gas. So is there hope for an industry so reliant on concrete to make a change to reduce their environmental impact? Fur rock, cited as less expensive, stronger, more flexible, and carbon-negative concrete, may be the solution for environmentally cautious builders. This is produced from approximately 95% recycled materials. And it is claimed to work as a sponge absorbing CO2. That'd be cool. Bioconcrete, yeah. Besides just reducing their footprint, builders have also been exploring how construction can get closer to becoming one with our environment. It's 80%. Oh, yeah, probably 80% American. That's that's too funny. Yeah, cedar wood shingles. Yeah, cedar wood shingles. Romans had underwater concrete for a long time. They didn't know how they produced it. if they even know now. Yeah, if they do even know now. Basically, like underwater concrete. I'm a little like I'm thinking like you would just pour like a prefab, like a precast, and then put it in the water, right? You don't form it in water. Or is that what they did? Like they formed it inside the water somehow? That would be. I would say they would have precasted it off outside the water, then put it in, or shored the water up, build their concrete forms, poured the concrete, and then let the water back in, type thing. Hey, Sylvia, Life in Holland. Good morning. How are you? Good to see you. Very good morning. I gotta make sure to. I'm missing. Oh, Jelly Duck. I should give Jelly Duck a wrench. There's Jelly Duck. I was just talking about you. There he is. I have to go over to my other system to do it, but I will. I'll give you a wrench by the end of the stream. Good to hear you're fine. That's awesome. And thanks, Jelly Duck. Thanks, man. I'm still here, by the way. Right on. Good stuff, buddy. Good to see. Good. I'm glad you're here, man. It's always interesting too because you guys have in Kuwait, you guys have different materials and a way different climate than we do, right? So here's the pollutant absorbing bricks. So pollution, aside from destroying our ozone, is contributing to issues like global climate change. Also has an impact on people. Shockingly, outdoor pollution causes more than 3 million deaths around the world each year. So outdoor pollution causes more than 3 million deaths around the world each year. That is a very high statistic. Very sad. Very sad. Wow. Primarily, pollution affects developing nations, also places where construction is beginning to flourish. In addition to using products that are produced more efficiently, new construction materials also can be used to improve the air we breathe. Pollutant-absorbing bricks are some of the latest innovations in the building industry that can enhance our atmosphere. Developed by a group of MIT students, these bricks are also cheaper than traditional bricks. Yeah, so cool. So it's similar to a vacuum cleaner. These bricks pull and cycle pollutants from the air, making the air cleaner and more breathable than before. Being tested in India right now. Country is suffering from heavy pollution. Yes, they do. Deaths are the leading cause of deaths. Hey, Zaphael, what's up, buddy? Yeah, thumbs up, guys. If you haven't hit the thumbs up button, hit it up for sure, guy. 0 thumb down is always good. Yeah. Lou Espinoza, hey. Good to see you. Hello. Good to see you guys. Some new faces in the chat. That's always good. Good to see you. Yeah, that's too funny. Yeah, Zaphael. How's it going, buddy? Happy Sunday Funday, guy. Oh, so the building integrated bioreactors are those algae panels. So they're literally producing energy and a protein based like a cattle feed almost, right? Which is really cool. In addition to bacteria, another living material might be highly beneficial in sustainable construction is algae. Algae, specifically algae fuel, has been long promised as an alternative to liquid fossil fuels. Although the reality of using algae for fuel still has a long way to go. The reality of powering our buildings with algae is here. Building integrated bioreactors include algae incorporated into flat panels. These flat panels are used in the building facade. So yeah, they pump with water. It's pretty neat. We saw a video at it on the beginning. So yeah, the 5-story building, the BIQ or whatever, I think it's the BIQ, the BIC building, is really awesome. So the buildings, we could definitely, without a doubt, build things that are 100% sustainable themselves, right? Self-sustainable. We have all this technology that can produce energy in like free energy, right? And it's amazing how we're not, like, it's not being pushed. Like, it's just crazy how all these power companies, you got the electric companies, you got gas companies, you got big oil, all these big money, finite mindset companies, right? Running everything, and it's insane the amount of money that we're talking about. Think about that. If you could free up all that money we pay to the oil industry and to the power companies, if we could free all that money up, put it all back into our pockets, it's going to go into other industry. You know, it's going to be more evenly spread. In my opinion, it's ludicrous that we're not, like, it's not legislated that we have to use these materials yet, right? It's not in building code or nothing, right? Well, I guess it's in the code if you're going to use it, right? There's going to be specific specifications written for the product, but I mean, when is the government going to start legislating these clean energy, like these self-sustaining, like buildings? Why are we not giving even tax breaks to companies that build these buildings? And the runoff, the energy runoff can be shared. Okay, why not have a shared facility where an energy runoff could help power like less fortunate people or less like people? You know, like, why can't we like do something like that? Right? Like, it's blowing my mind. It blows my mind. Oh yeah, we've seen actually a lot of this stuff here, eh? I think we've seen this page like probably 3 times, but greed rules. Yeah, greed is insane. Greed rules the world. It's really sad. It's really, really sad. And being in construction and in the trades, and being like being as environmentally cautious like I am, it's sad. It's really hard seeing how we build things. We're so wasteful. It blows my mind, man. In new construction, how like we're sending bin after bin after bin off to the dump. It blows my mind. And at the very least, leads to be mandated. You know, recycling programs should be implemented into every single construction project, but it's not. It's like 1 in 50, 1 in 100 maybe, that construction products recycle. Love this. Translucent wood is cool. Yeah, the cigarette butts to make bricks, right? So cigarette butts to make bricks. This is... Okay, wait a minute. Which one's this one here? The floating piers. 3-kilometer walkway wrapped in 100,000 square meters of yellow cloth and a floating dock system consisting of 220,000 cubes of high-density polyethylene. And so this stuff here, I believe, is very environmentally friendly as well. But this whole island is built on these polyethylene high-density cubes. And the walkway here, right? and then it's got that cloth. That's a really interesting... Yeah, that's right. So rich, Sapphire, they can build their own island, and that's exactly what happened. This guy, this whole island, and this is a pretty cool. Let me see here. If I could go, Christian and Jean-Claude's floating piers. Yeah, I'm gonna research it on YouTube. I'll show you a video on it. It's pretty impressive. Yeah, they're artists, right. Floating piers, I believe, is what the project was called. Yeah, here we go. I would love my own island. Yeah, who wouldn't? So Christo and Jean-Claude, or whatever, there's the artist. They made this. They're artists behind this. Rich guy hired them to build this floating pier project, right? Where I don't know if there's any talking on this, but so look at that, eh? I could see the cloth getting really, really dirty. Yeah, it would be cooler if it wasn't neon yellow. Yeah, yeah. Who wouldn't love their own island though? I would love that. It would be sweet. Oh, look at this. This is just like a walk bridge. This isn't even the. This is something different. Yeah, because like, what is with that cloth, right? That is kind of weird. Be cool to fish off of, yeah. Okay, so this isn't the one anyways. Let's see here. Here's the other one here. Actually, I think this is the good one here. That's a different one. That bridge. That's a different one I haven't seen before. All right. Oh yeah, it's right around from the castle. What a beautiful follow the orange cloth, right? Not the yellow brick road, the orange brick road, the orange cloth road, yeah. It's like a beach, like a party beach. That's wicked. Like, and then this is a private residence, I believe. Well, it's not very private with all them people. Holy cow! What an attraction. Yeah, it looks like a festival. Yeah, it does, right? That's really, really cool. Oh, look at that. There's more of it, it looks like. Yeah, it's right. It is an island. Yep. It is an actual island. There's a house on it, too. Yeah, it's pretty cool. Yeah. Oh, so this is opening day. So this is the opening lay on piers on Lake Iseo, Italy. Yeah, Italy. I knew it was in Italy. So this is opening day. So it's going to be quite popular, obviously, on opening day. Speaking of orange, is this Trump quarantined of corona exposure? That's funny. Coronavirus exposure. That's too funny. Yeah, that's pretty neat. But yeah, isn't that really cool? You found an island for sale in Canada for only $26,000? Is it big enough to put a house on? Yeah, this is cool. Will this be the concrete used to build on Mars? So yeah, assuming that when we finally colonize Mars, water will be one of our most valuable resources. The Northwestern University team sought an alternative to the usual concrete mix required to make concrete. They opted for a technology that has been in development since the early 1970s, sulfur-based concrete. Blocking a river, right, yeah. Sure, it's not a sandbar with a tent. Yeah, the one that's blocking the river, that is weird, right? Because yeah, like I guess they don't have boats on that river. This is neat, eh? The luminant cement. Cement with the capacity to absorb and irradiate light energy in order to provide concrete with more functionality and versatility from an energy efficiency standpoint. That's cool. And if you can control the design of the way the light, that's really awesome. Yeah, you see this seismic, the world's lightest anti-seismic reinforcement. The Japanese company Komatsu Serene Fabric Laboratory has created a new thermoplastic carbon fiber called Capcoma Strand Rod. Yeah, the Strand Rod. Yeah, it's really neat. The carbon fiber is covered with synthetic and inorganic fibers, then coated with a thermoplastic resin. The new fiber, created by Kengo Kuma, has been tested on the exterior of the company's headquarters in Japan. They're really strong strand rod. They'll be using strand rod in the Smart Lab City. 3D printed biodegradable furniture. There you go. Pollution absorbing brick. So Breathe Brick is designed to be a part of a building's normal ventilation system with a double layer brick facade with specialized bricks on the outside, complemented by an inner layer that provides standard insulation. The concept behind Breathe Brick is cyclone filtration, an idea taken from modern vacuum cleaners, with separate heavy contaminating particles from the air and drops them into a removable hopper at the base of the wall. That's different. Hen Island, Ontario. Oh, it's in Ontario too. That's cool. That's where I'm from, is Ontario. Yeah, Ontario. IKEA already makes 3D biodegradable furniture. Yeah, without a doubt. Without a doubt. That's different. So Breathe Brick. Let's see if I can find something on Breathe Brick. Okay, here's here's the most recent one. PrivateIslandsOnline.com. Haha, right on. I'll have to check that out. I can't. Oh, so what's this? Your porous concrete module forms an air filtration facade.
It is a masonry system that filters polluted outdoor air so that it becomes healthy enough to bring it to the occupied space. It is first developed by California Polytechnic State University. It is a passive system for improving the air quality and also used for load-bearing walls.
Oh, that's too funny. A membership opportunity, not an island for sale. Please read below for full details. There has to be a catch, yeah. That's right. That's right. That's not a real price, yeah, no.
So this is the image of Breathe Brick wall. It has a particulate collection stack in which the pollutants will be collected and moved to the accessible hooper. It is a hooper which is accessible so that the polluted particles can be removed when it is full. The structural reinforcement is provided for the structural stability of the wall. Breathe Bricks works on the principle of cyclonic technology. So, what is cyclonic technology? It is a process in which the physical particles are removed from fluid or air by vortex separation. It is very similar to the operation of...
Interesting. I mean, this is the first time I've seen this before.
Cyclonic technology. Here the baffles are there. The outdoor air, that is the polluted outdoor air, will be passed into it, and the clean air will be moved to the occupied space where the dust will be collected in the dust hooper.
So Breathe Brick Systems removes 30% of fine particles.
30%
Yeah.
of fine.
Yeah, that's really, really cool. Interesting. Yeah, that's new. Oh yeah, self-healing concrete. That's awesome. Whoa, look at that here. Cupola clad. That's a sweet design. Natural slate design offset. I like that. That's cool. Right on. Yeah, then I think these is all just random stuff I found. I don't think there's anything interesting in here. Nope. Yeah, materials and fashion. Oh, look at that. Look at that countertop. That is beautiful. Oh, low pressure foam link. I just shut the darn link. I think, do I have it? I don't know if I saved it. Let's see here. Yeah, this. Oh, yeah. Check this here. Oh, yeah. I'll try to bring it up. I think I have the link here. I'm just checking to see. Okay, I think I have the link. No, shite. I didn't keep all of them. No, I don't. Darn it. Sorry, buddy. But I can, low pressure foam. You want to look at that? Patent foam buddy, patent pending. Yeah, I know. I didn't save that damn link. So I don't know what I think of this, honestly. For inside the wall like this. Okay, so spraying it in the wall like this, like look at how it's for one, it's. Look at all the backing they used, like for the joints on the, like that's just backing, like random backing. Oh, that's messy. So I don't like this spraying it in the, this spraying it on the drywall in the wall. Look at the mess. Like it's all gonna be like, how do you make it perfectly even, you know, and so that it doesn't come out of the wall. Are you gonna have to come back and shave it, and then you can see air pockets right now. You can see air pockets. So how will that affect the like moisture and you know, like condensation, right, from building up and mold creating behind the board? You know, is that gonna? I don't know. I just don't know what I don't know about this. Small jobs, yeah, like, and if you're not, like, say if you're not gonna drywall that other side, then maybe too, right? Like, I don't know. Spray on insulation. I don't see how this could work. It definitely not quicker. It's definitely not quicker to install. That's for sure. It takes a lot longer to install. Yeah, there is no channel as well. Yes, good point. Good. There's no wall channel in there. Well, I guess you don't really need it if you're doing it this way. But yeah, look at this random backing. That's what they used to, whatever they, on the other side of this wall, they used to hold it up with, right? Like that's, so when they unscrew it and try to replace it, the backing is just going to fall. Oh, I guess this won't fall anywhere if it's sprayed in like that. But look at how long it is taking. I would have had this whole wall insulated like 5 minutes ago. I would have had this whole wall insulated. And this guy's still spraying in the third cavity, right? Could have anti-mold in the foam. Okay, yeah. Closed cell foam is 100% vapor barrier. Yeah, but to me though, like yeah, the foam itself is, but the air pockets that don't have the foam between the foam and the drywall aren't, right? I don't know. I'm not so sure about that one. And I don't know how environmentally friendly that product is either. I have no idea. But it is taking a long time to do this wall. Like, wow, a really long time. You see how old the drywall is there? Did you see how old that? Look at that yellow ass drywall. That's been hanging there for a long time. Oh, they're right there on the end of the desk there. Right there.
Okay. I'm organizing that.
Okay.
This is a mess. We need to be better.
What? Oh yeah, you know, I got tons of stuff.
Not good.
I know. Oh yeah, look at these companies here, guy. Hey, brother. Hey, right on, Matt. Dude, nice, man. That's my buddy Matt, guys. From Ontario. Thanks, man. Yeah, buddy. I just been working on the setup, dude. Resetting things up, and yeah, man. Thanks, buddy. Good to see you, man. That's awesome. Yeah, that's my best buddy from Ontario, guys. That's awesome, man. Good to see you, bud. Good to see you, man. Yeah, so that's pretty much it. I'm gonna click over again to my full screen, and man, let's hopefully it works. Yes, it works. Good. I'll get over to here. Everything is working good. It looks like. So awesome, dudes. So that was some awesome material. I think that was good. I like how I think everything went nice and smooth on the stream, and yeah, man, wow. What was your favorite material? I really liked that the air, the wind power thing, Amos. I have the page still open over here. What was that called here? Oh, what? Don't tell me I shut that down too. Amos, tell me again. What was that wind power, that portable wind power thing? The name of it again. I don't want to forget it. But yeah, man. Make sure this isn't too loud. There we go. Cool. Everything looks good. Beautiful, man. AirGen. Yes. Thank you. Yes. Right on. Right on, man. AirGen. Music is fine. Everything's good. Perfect. Yeah, portable wind beans. Yeah, I like that AirGen. That was cool. Yeah. I'm gonna download the blueprints for that. See if we can build one, maybe. He says that they're out there, right? It's share text, so that's awesome, man. Very cool, man. Very cool. Very cool, buddy. My buddy Matt's here, man. That's sweet. That's awesome. Oh man, I am pretty happy with how this works. I got the day off tomorrow. I think that's even more exciting. I have having the day off tomorrow. That's going to be awesome. I'm going to shoot at least one video tomorrow. But I'm doing a new series on. It's called Tips for New Construction Workers, and it's a new series of videos. It'll be a little bit more me talking head type video with some explanations. But there's older videos that I gotta redo, man. I gotta get them out there. They're definitely very high demand on my channel. So I got a series. I think there's like 7 videos I'm gonna shoot. And yeah, you bet, Jelly Duck, Ahmed, right? I'm going to shut her down here in a minute. So thank you so much, man. Yeah, tip 1, slack a lot and let the old guys do all the work. Yeah, that seems to be a trend nowadays. So I'm not surprised. But dudes, man, yeah, it was a good stream, man. Very good stream. I love seeing everybody. So good to see Matt coming in. That's awesome, buddy. But yeah, if you guys have any suggestions along the way, let me know. Especially because I almost forget what it's like to be new, and that's kind of the point here. I got to kind of put myself in a new person's shoes again, and try to just walk them through it. I don't know if you guys seen To the Top Cranes video that he put out this last week. Jimmy from the To the Top Crane put out, talking about how all the money and education is going to like Ivy League schools or universities, and nothing's going into trade school. And guys, I am so fearful for the future of this industry, because there is no young kids coming into it, right? There's no, and definitely like it's just there's just no attraction to construction anymore, right? Like nobody wants to work in the trades. Thanks, Raphael. Right on, dude. I got another drywall video coming out on stand-ups. So I just did the framing video, so then I also drywalled that wall, and it's interesting because of all the pipes and stuff that I was like an acrobat up there on the lift, right? So I did a time lapse, so I'm gonna try to do some stop motion with that video, but that video will probably take a couple weeks to come out, the drywall one, because it's gonna be quite an edit. But I will be putting out a video on the tips for new construction workers series this week for sure. But thanks, man. Thank you, everybody, so much for coming. I'm going to shut her down. It's always awesome to see you guys. And again, we're going to see you on Friday night. This is coming Friday night. Now that the 2 PC streams, everything's set up here, I might do more live streams, okay? Because this is a mint rig, so we'll try to get some more lives in. But always good to see you guys. Sapphire, Mark, Me Dibble, Jelly Duck, Mr. Ahmed, Matt, Lone Shark, and yeah, thumbs up, man. Give me a thumbs up on the video before you leave. That'd be great. Hey, Kevin, how's it going, big guy? Good to see you, pal. Good to see you, man. Just shutting her down, but good to see you, man. Thanks for stopping by. And if I missed you on the goodbyes, doesn't mean I don't love you, because I do. I love you. I love today, and today is awesome. I love your beautiful faces. Yeah, baby. You guys have a wonderful day and a really awesome week. And I'll see you next time. Bye for now.